talk and talk speed.
Well, we appreciate that. So we can't do without you.
Launch command on this stuff.
We have a launch commit and we have a liftoff. The swing team moving back. We clear the tower.
Roger, clear the tower.
Houston is now controlling.
Not so long ago, we left our Earth for the first time to explore a neighboring world in the solar system.
Well, Houston, Suite 16 has arrived.
Roger 16, copy you loud and clear.
We found a fascinating place, but barren and lifeless.
We stopped, and let's take a gander around and see which way we ought to head. You know, Dave, if we can make it out that far directly ahead of us, look at those large blocks. You mean us? Come down slope, yeah, at 12 o'clock.
One sight stood out from all the others. When we looked back across the moon's horizon, we saw the Earth, our home, a tiny oasis beckoning across all those miles of empty space.
I tell you, it looks beautiful going away, and it's going to look even better coming back.
To look at our Earth from the outside is to discover an entirely new planet. We can see familiar landforms, like Florida and the Bahamas. But what's most striking from space is that our world, unlike any other we know of, is a world of water. 2/3 of it is covered by ocean, glistening in layers of blue and turquoise through a delicate filigree of cloud. All of it is wrapped in a thin layer of air, shielding its surface from the harsh radiation and cold vacuum of space. If it weren't for this fragile cocoon, our beautiful planet would be as dry and lifeless as our nearest neighbors in the solar system. Mars has only a feeble atmosphere. It's locked in a permanent ice age. Venus, under a very dense atmosphere, is hotter than an oven. Nothing could live here. As far as we know, only the Earth can support life. To learn more about the unique environment which makes life possible here on Earth, we're now returning to space in a variety of craft. We call this Mission to Planet Earth. Only a few hundred people have actually seen the Earth from space. Here we can see it as a whole. Floating beneath us, Sri Lanka and India. But now we also see a planet, bathed in the light of a nearby star, the Sun. Ours is a world of constant change. shaped and reshaped by nature's powerful forces. Its blueness came out of the earth itself. The ancient oceans were steamed out of the interior by erupting volcanoes. We know this one as the Big Island of Hawaii. Now, whole continents appear. Europe is on the left. Stretching beyond Gibraltar to the horizon, the Mediterranean Sea. On the right, Africa. Deep in the heart of Africa, we come upon a land of forests, lakes, and rivers. We're crossing over Lake Victoria and the broad plain of the Serengeti. Here beneath us, our planet's systems of water, earth, and air interact to sustain life. To observe this complex environment more closely, we'll drop down to the surface of the strange red lake below. This is Lake Natron. It's hard to believe any life could exist here. But in fact, the lurid color is the life itself. The water is teeming with red algae that feed on white soda from nearby volcanoes. Ash, spewing from these volcanoes for millions of years, nourished the great grasslands of the Serengeti, where a wondrous array of species evolved. Each depends in some way upon the others. Every link between animals and plants is a strand in the rich fabric of life on Earth. Of all the creatures that evolved in Africa, only one stood upright. Only one developed tools and language. For about 1 million years, humans were hunters and gatherers. Then we discovered farming. Now the same land could support many more people. But without the Earth's life support system of water and air, not a living thing could exist. "200 miles above the Earth, there is no air. This astronaut must wear a spacesuit. It supplies the oxygen he needs and insulates his body from extreme heat and cold. Inside, the orbiter functions somewhat like a miniature Earth. The environment is carefully balanced to keep the astronauts comfortable. One system controls the temperature. Another supplies oxygen. On Earth, the forests and oceans absorb the carbon dioxide we exhale. In space, the crew uses special canisters to clean the air. For a short time, this artificial system supplies to the astronauts what the Earth has always provided for us. Its natural systems slowly recycle the air, the water, and even the rock. In one cycle, Heat from the sun evaporates water from the ocean to form clouds. Winds drive the clouds over land. Rain from the clouds falls back to the earth and then runs down to the sea, where the cycle begins once more. Heat stored in the clouds can drive them upwards into towering thunderheads. Inside them, powerful electric charges are building. You can see lightning on Earth from space. Astronaut Charlie Bolden.
Probably my favorite spectacular view is nighttime, watching lightning all over the Earth as it goes from cloud top to cloud top over hundreds of miles, almost as if somebody's conducting an orchestra, you know, and the lights flashing in response to the music and everything. You kind of float up in the window and look for long periods of time in amazement at what's going on down there.
In places where there is a lot of rainfall, an abundance of life springs forth. The plants produce oxygen, which we and the other animals breathe. Life on Earth is easy to see from space. Costa Rica and Panama are green with it. But other places in the world get almost no rain. In the Namib Desert, only wind has shaped the surface, sweeping the parched sand into dunes nearly 1,000 feet high. In some of the driest deserts, people have drilled for water trapped in the rocks deep below the sand. Each one of these tiny circles is an irrigated field, half a mile in diameter. But this is a short-term gain. It will take only 50 years to use up all the water, but more than 10,000 years to replace it. In some regions, like the Sahara, the amount of rainfall can change drastically within a single generation. When we started looking at Lake Chad from space, we saw that it was shrinking. Soon, a wave of droughts brought starvation to the people living here. We don't know why these local changes occur, but we do know that the Earth's climate as a whole has changed over much longer periods. During the last million years, great sheets of ice advanced and retreated several times, burying northern Europe and much of North America. This is the Hubbard Glacier in Alaska. Trapped deep inside these frozen walls is a record of climate change, going back thousands of years. By analyzing samples of the ancient ice, we may learn to predict our future climate. "10,000 years from now, Perhaps the sites of Montreal, Detroit, and Copenhagen will again lie buried beneath a mile of ice.
It's moving. Looks good.
To observe large-scale changes on the Earth, we use satellites. The TDRS satellite will act as a relay, linking scientists with dozens of spacecraft watching different parts of the globe. Some study ocean currents. Others monitor the health of crops. They also warn us when storms develop. Of all the storms, the most dangerous and unpredictable are hurricanes. Without help from satellites, we could not prepare ourselves for the onslaught.
Are advising voluntary evacuation of the barrier islands.
Hurricane Hugo, after ravaging Puerto Rico, tore into South Carolina. What was once a national forest is now a heap of kindling. Where once there was a house, only the front steps remain. Overnight, nature's fury has devastated entire communities. But then, as quickly as it struck, the storm vanishes and the eastern seaboard is calm once more. There are, however, other catastrophic events affecting our planet. They're far more violent than any storm. The Earth is continually pelted by a hail of objects from space. Most are tiny and burn up in the atmosphere. But every now and then, a big one gets through. Some 30,000 years ago, a piece of an asteroid, weighing perhaps 300,000 tons, slammed into Arizona. It blasted out a crater almost 600 feet deep. As collisions go, it was a small one. From space, we can see the scars from much bigger impacts on Earth. This one in Canada is 60 miles across. The effects of a similar collision may have wiped out the dinosaurs. The young Earth was once completely covered by impact craters, but most of them have been erased by the powerful forces which keep changing the face of our planet. From orbit, we see evidence for the most astonishing geological discovery of our time. The Earth's crust is broken into about a dozen moving plates. Here, a giant crack extends out to the right from the Sinai Peninsula through the Dead Sea. In a closer view, you can see how the Sinai, shaped like a triangle, has wrenched away from Saudi Arabia on the far right. The rift that opened between them lies under the Gulf of Aqaba. Most of the rifts are on the sea floor. To search for them, we need vehicles similar to spaceships. We are on a journey 2 miles down to the very bottom of the ocean. We will enter a world that has never seen sunlight. And yet, the ocean floor is alive with exotic creatures. They thrive on nutrients in the water, which is heated by the Earth's great furnace beneath. Here in mid-ocean, at the boundary between two plates, molten rock pushes up from the interior. These lava chimneys are actually miniature volcanoes. Just as one of the Earth's systems recycles water, another recycles rock. As new crust is added to the Earth's surface here, the other edge of the plate, perhaps thousands of miles away, sinks back into the Earth's interior. As it melts, volcanoes erupt. This is Sakurajima volcano in Japan. You can see its smoke all the way from space. Here, two great plates are slowly crushing together, pushing up the Himalayas, the highest mountain range on Earth. From just beneath us, the snow-capped peaks stretch over 1,000 miles towards the horizon on the left. Almost all of North America, here on the right, lies upon a single plate. On the left, the Pacific Plate is sliding northward past it at the stately pace of a half-inch per year. The Gulf of California, in the center, marks the boundary between the two plates. Along this boundary, the infamous San Andreas Fault runs northward. Using satellite pictures, a computer can take us on an imaginary flight along the San Andreas. The actual height of the terrain has been exaggerated to accent the network of valleys formed by the fault's many traces. As the two plates slide past one another, they lock together in some places. The strain builds. Near San Francisco, the strain reaches the breaking point. Something has to give. And when it does, we are rocked by an earthquake. Magnified by the computer, first a sharp wave traveling at 10,000 miles an hour moves out from the epicenter. Then comes a series of rolling waves. These inflict most of the damage.
Efforts to rescue came last night. All sorts of people, cops, firemen, people they do, risk their lives to rescue strangers.
Everything started shaking, and I started running. I didn't know where to run because I was getting too scared, and my mom couldn't get me because the floor was moving too hard.
Some buildings, though still standing, had to be demolished. In time, the houses and highways are rebuilt, better designed to withstand the next earthquake. People will always be subject to nature's powerful whims. In Japan, another fault zone, millions live with the same uncertainty. One day, almost certainly, we'll learn to predict earthquakes. But in the meantime, we try to live in harmony with our sometimes turbulent planet. After each salt, we pick up the pieces and carry on. And sometimes we wonder if there could be any other place as wonderful in all the universe. But now a new force, as threatening as any in nature, has begun to change the earth. We are that force. To our ancestors only a few centuries ago, the forests, oceans, and skies seemed vast and almost limitless. But all that has changed. It is only now that we can see it from space that we realize the magnitude of what we are doing to the earth. As settlers cleared land to create the great farms of the American Midwest, more and more valuable topsoil eroded into the Mississippi. Flowing southward down this great river, the silt is carrying pesticides. They are pouring into the Gulf of Mexico. The Yangtze River in China is a natural conveyor belt for soil from the plateau above it. Now it doubles as a dump for sewage and industrial wastes. But an island far away has become the most eroded place on Earth. Madagascar was once cloaked in lush forest. Now loggers and farmers have cut most of it down. With nothing to cling to, the thin red soil has washed down the mountain slopes into the Betsaboka River, choking its mouth completely. Off the coast of South America, the Atlantic is awash with brown sediment, pouring out from the Orinoco and the Amazon. Upriver lies the largest continuous rainforest in the world. This is home to nearly half of all the species found on Earth. They are sheltered from sun and wind by its great moist canopy. People depend upon the rainforest for food and the rare medicines its plants produce. Like those who settled Europe and North America, people in search of a better life are clearing the land for farming. The cut trees are left to dry, then burned. Almost 1 acre of tropical rainforest is destroyed every second. Some 100 species, most of which we've never even seen, are driven to extinction every day, lost to the planet forever. In destroying them, we are tampering with the fabric of life, cutting the very strands that bind us all together. Only from space can you see how much is burning. The smoke spreads thousands of miles across to the Andes Mountains. Soon we will see roads here, then farms. Towns will expand to cities. Eight million people live here in Los Angeles. 6 million vehicles and thousands of factories release chemicals into the atmosphere. Smog permeates the air we breathe. Not only are we polluting our air, we may also be altering our climate. Around the globe, cars and factories belch huge amounts of carbon dioxide into the air, faster than our oceans and depleted forests can absorb it. Our numbers are increasing by nearly 100 million every year. We consume enough energy to be visible all the way from space. There are now more than 5 billion of us spread across the Earth. In this satellite view, you can see the continents outlined by the lights of the great coastal cities. In North America, in Europe and in Asia. But our planet does have limits. The carbon dioxide and other greenhouse gases we produce act like a blanket, trapping the sun's heat inside our atmosphere. Beneath it, the Earth's temperature may be rising. Without intending it, we are now conducting an uncontrolled experiment on the Earth's life support system, and we cannot predict the consequences. but already there are clues. High in the stratosphere, a thin layer of ozone shields us from the sun's deadly ultraviolet rays. You can't see the ozone, but our satellites and other instruments have detected a hole bigger than Europe in the ozone over Antarctica. We have created the hole with chemicals we use in our everyday lives. Faced with this evidence, the nations of the world recently agreed to restrict and eventually ban production of those chemicals. Looking out past the shuttle's tail, astronaut Jim Buckley.
Look at how thin the atmosphere is. Everything beyond that thin blue line is a void of space, and everything below it is what it takes to sustain life. And everything that we do, to this environment and our quality of life is below that little thin blue line. That's the only difference between what we enjoy here on Earth and the really harsh, uninhabitable blackness of space. And it's not very wide, is it?
Our world is a special place where millions of species coexist, each one an integral part of our planet's fabric. What we do will determine their fate and ours. We can undo the damage we have caused. The earth we inherited can again be a garden, beautiful and bountiful. Everything we need for life is here. Shimmering blue, it is our haven in a vast black sea of space. This is our home. It will be home to our children and to their great-grandchildren. It is home to all the nations of the world. It's home to the people of Mexico. Home to the people of Greece and Turkey. It's home to Israelis and Arabs. It's home to the Vietnamese. It's home to the Aboriginal people and the farmers of the Australian outback. It's home to the people of Japan. It's home to the peoples of the Caribbean. It's home to all of us. And it's our only home.